the sample proportion is related to binomial distribution. Therefore, you may wonder, shall we say the p hat is binomially distributed? Now here I have to tell you, no. Okay. According to the central limit theory, the p hat is normally distributed. Okay. Now here you may wonder, okay, why is like that? Okay. Unfortunately, at this level, you don't have to know that much. And also, you just need to remember two things. Okay. The first thing is central limit theory. Okay. Central limit theory. Remember this term. State that the sampling distribution of the sample proportion approaches normal distribution. So we always remember if the question asks about the distribution of sample proportion, the answer is the same. The distribution of sample proportion is approximately normally distributed. Okay. Second, under what condition? Okay, the condition is sample size has to be at least 30. And then second condition, sample size times the probability of success, at least 10. Sample size times the probability of failure, that is 1 minus p, is also at least 10. Okay, and then you may see, why here write more than 5, less than, more than, why here is more than 5? Now ignore that. Okay, ignore that. That's why I say you just need to take note of two things. Number one, distribution of sample proportion is normal. Okay. Secondly, condition is n at least 30, nq at least 10. Now that is central limit theory. Okay. For those who do math specialist, you may learn the central limit theory used for sample mean. But for MAM, math methods, just focus on this one. That would. Okay, we look at the question now. Example 1, it is known that 85% of students starting school in a particular state have been immunized against the measles. Sample of 250 students starting school were taken. Describe the probability distribution for the sampling distribution of sample proportion of size 250 for students immunized against the measles. Okay, now they ask you describe the probability distribution for sample proportion, right? So of course it's normal. Okay, you may say approximately normal or normal. That's okay. Normal distribution. But you cannot stop there. Normal distribution has two parameters, the mean and the standard deviation. So you also need to calculate that. So the mean, remember previously we learned the mean of p hat is p. So here the mean is 0.85 since 85% is the population proportion. Okay, because it is known that 85% of students. So this is not 85% from a certain sample. This is known to be 85% of all students in this particular state. And then the standard deviation is square root of population proportion times 1 minus it over the sample size. So 0.85, 1 minus 0.85 divided by sample size, taking the square root. Okay, and then you can rewrite as sample proportion follow normal distribution 0.85, 0.02258 squared, like that. Okay, usually the question, question like this, you don't have to verify the condition. Since they ask you to describe the probability distribution, is normal distribution already. But we can still check. The sample is 250, at least 30 already, right? N times P, 250 times 0.85. Yeah, so 250 times 0.85. 212.5. More than equal to 10 already. N times Q, 250 times 0.15. 37.5, also more than 10. Now that's why definitely we can say p hat is normally distributed. Okay, after we know p hat is normally distributed, we may need to solve the question that asks about the probability for p hat in an interval. Okay, so like this one, they ask you what percentage of values of p hat would lie between 0.45 and 0.55 for a sample with n equals 80 and p equals 0.4. So we write down the probability expression. So p probability for p hat lies between 0.45, 0.55. Okay, and then the mean of p hat 80 times 0.4, that is 20. The standard deviation p hat okay, 1 minus 0.4 is 0.6. Square root of sample size. Okay, so this one I need to calculate. Zero point 0.0548. Zero point 0.0548. Okay, so p hat is normally distributed. What I'm doing, you may notice I made a mistake already. It's p 0.4. Okay, sorry. Just now I write the p hat mean of p hat wrongly. Okay, so p hat should be normally distributed like this. So use your calculator, normal CDF. Okay, which is you press menu, number 5, probability, number 5, distribution, number 2, normal CDF. Lower limit 0.45, upper limit 0.55, mean 0.4, standard deviation 0.0548. Okay, so you can get the probability 0.178 converted to 17.8%. Now, example 2. Find the probability for p hat lies between 0.5 and 0.6. Now you can try the question yourself first. Okay. So firstly, we know it's gonna be normal distribution. That's why I'm going to use normal CDF. Okay, lower bound 0.5, upper bound 0.6. The mean 0.45, right? The mean of p hat is same as p 0.45. And then the standard deviation of p hat, once again, square root of p 1 minus p over sample size. Zero point 0.04975. Okay, so you can calculate, you get the probability 0.156. Okay, so in summary, p hat is normally distributed. Okay, p hat is normally distributed. Whenever the question asks about the distribution of sample proportion, we should consider is normal distribution. This is the mean, and this is the standard deviation. That is why see here asks about the z value of p hat. If you calculate the z value of the p hat, should be the p hat. Okay, that is x minus the mean divided by the standard deviation.